Hi guys, we're going to take our notes right now. So you should have your digital interactive notebook pulled up. You should have unit 2A. Your example should be open to page, I believe it's 19 and 20. Those are the three examples we're going to do today. You should have hopefully already put your name right here on your notebook so that we know whose it is, that it's yours, okay? Then I need you guys to go ahead and go over to slide 6 for me, please, and you're gonna go ahead and type this in blue. I already typed it in. It's page 9 and 10 that we're gonna be doing today. So a little bit, page 9 and 10 is what we're going to be doing, and then the page title is add and subtract polynomials. So you can pause here if you need to get that typed in, and then we're going to head over to slide number 9. So slide number 9, we're going to fill in anywhere we have these like little blue lines. We're going to go ahead and you can kind of erase those and type them in. I'm handwriting, but you guys can just go ahead and type on there. Okay. All right. So today we're adding and subtracting polynomials. It's not new. It's review. It's stuff you guys have done before. It should be pretty easy. So to add and subtract polynomials, simply combine like terms. So hopefully you guys remember what it means to be like terms. So to be like doesn't mean they have to be exactly the same. In order to be like terms, they do have to have the same variable or variables. I'm going to put an S in kind of parentheses right here because it could have more than one variable. But what they will have, and they will also have the same exponents on those variables. So it might be just one exponent. It could be 2 exponents or 3, however many variables there are. What can be different on like terms is the coefficients, the numbers in front of those variables. Okay, so that's what we're going to look at today is combining like terms. What you do in order to combine like terms is you add the coefficients but you keep the variables. Variable, whether you have 1 or 2. Okay, so same variables, same exponents, different coefficients. You keep those variables that are the same, but the coefficients are what you add. If you are asked to subtract polynomials, it's really similar to adding polynomials. All you have to do is first distribute the negative and then combine like terms. So subtracting is technically the same as adding, but you have a small step of distributing the negative before, okay? All right, so here, this little chart right here, it's just adding and subtracting integers. If you're adding integers and they have the same sign, so they're either both positive, both negative, all you have to do is add the numbers and keep the sign, basically. So if you're adding 2 plus 2, those are both positive. You add 2 plus 2, you get 4, you keep it positive. But if you're adding -2 and -2, you just add 2 and 2 and get 4, but since they were both negative, you keep it negative. So that's these two right here that I'm talking about. If the signs are different, so let's say -5 and +2. So -5 and +2. You do the bigger number minus the smallest number, and then you take the sign of the bigger. So say, like I said, it was -5 and +2. Well, when you add those together, you actually subtract 5 minus 2, get 3, but you keep the sign of the bigger. The bigger number was negative, so your answer is going to be -3. Okay, so that's not anything you have to like write down or anything, but I just wanted you guys to kind of keep that in mind. Okay, that's this right here. All right, so this next little part is where we're going to do a little drag and drop. What you're going to do is you're going to take these little boxes right here and you're going to drag them and you're going to drop them if they're like terms in the same box. So I'm going to go ahead and start with my -2x. It's the first one, so I don't have anywhere else to put it, so I'm just going to put it in this first box, okay? You are actually clicking and dragging the whole box in there, not writing it. Then the number 3. Well, is 3 like with -2x? No, because this has an x and this one doesn't, so they don't have the same variable. So I'm going to go ahead and just move this 3 over here. So remember, you're just clicking and dragging it. I'm just writing it over here. The next one says -4x. Is that like with -2x or with 3? Well, they both have an x. The numbers in front are different, but they both have an x, and their exponents are the same. So I'm going to drag this negative 4x just down to this box. Then number 5, that's a constant, no variable. So it actually goes with the 3 because it's also a constant. My next one says negative 4x squared. So these ones have x's, but it doesn't go in this box because these are x's. This is an x squared. So this one is actually going to get dragged all the way down to this little bottom one, negative 4x squared. 11 is a constant, so it's going to go with the other constants. Negative 15x, that's going to go with the other x's. 2x squared has a squared on there, so we're going to move it with the other x squared. So you're dragging it all the way down over here. And then negative 15, that's a constant, so it's going to go in the constant box. All right, when you actually write your polynomial, so your polynomial will go in this blue box down here at the bottom, you always start with your highest exponent first. So my highest exponent is this x squared. So again, you add the coefficients, that's these two numbers in front. You keep the variables the same. They're different signs. One's negative, one's positive. So negative 4 plus 2 is going to be 2 because it's 4 minus 2, but then the bigger sign's negative, so I'm going to keep the negative. And then it's an x squared. Then we move to the next down decreasing order, descending order. So we go to the x's. I have a negative 2, a negative 4, and a negative 15. All those coefficients are negative. So you're just going to add them all up and keep it negative. So my answer is going to be negative, but I'm going to add 2 plus 4 plus 15. That's 6 plus 15 is 21. And then you keep the variable, so it's x. So you add the numbers, keep the variable x. It's like you have 2 bananas, 4 bananas, 15 bananas. You add all the bananas together, you have 21 bananas. The x doesn't change. And the last one is the constants. So these 3 are positives. I'm going to add those together first. 3, 5, and 11, that equals what, 19? And then 19 minus 15 is 4. When you guys are actually typing in your answer, to do this little squared right here, you might have to do like negative 2x and then this little symbol squared. This little, they call it a caret, but you have to hit shift 6. Okay, so you guys don't have some of these markings, I guess, on your notes of what you're doing. You just have that you moved them to the boxes and then typed in your answer down here. All right, now let's go to our examples page. This should be page 19 and 20, I believe. We're going to do 4 examples. Okay, so my not 4 examples. We're actually going to do 3 examples, I believe. Let me double check. Yeah, just 3 examples. So it says adding and subtracting polynomials. Example 1 says simplify 2x squared plus x plus 10 plus 7x squared plus 14. So this first step, it tells you rewrite the sum so any like terms are together. I wouldn't normally actually have you guys do this step, but they want you to like how we moved them into the boxes. They want you to write them together. So this one is an x squared and this was an x squared. So they want you to write them together. So same variable, same exponents. Then the next one is an x. Well, there's nothing to go with that guy, so we're just going to put him here. And then the next one is constants, 10 and 14. So we'll write those at the end. Then you just want to go ahead and it says find the sum of the constant term. So it wants us to add these two together. Well, 10 plus 14 is just 24. Over here we have plus x. There's nothing to add with it, so I'll just move it down to plus x. And then we're going to add the x squared term. So we have 2x squareds and 7x squared. So we have 2 here, 7 here. That means we have a total of 9x squareds. And that's just our answer. So we did step 3, I guess, up here. Okay. All right, let's go to example 2. So again, I'm telling you, you don't have to rewrite them and list them. One thing would be like color coding them or doing different shapes. So I'll try the shapes one because in case you guys just have a pencil. So you always start with your highest exponent. So my highest exponent is 4. So 6x to the 4th. Are there any other x to the 4ths? No. So I'm going to start with that one. It goes first. Then I work my way down. I'm going to go to x cubes. So I see an x cube here. I'm going to put a triangle around it this time. And then I look for any other x cubes. and then I would add those together. So I have 10 here and negative 1 here. So this is just 10 minus 1, so that's positive 9x cubed. I'm just going to go down in descending order, remember? So now I'm going to go to x squared. I'm going to put a square around it this time. I have negative 3x squared, negative 4x squared. So notice how they're both negatives. That means I'm going to keep it negative, but I'm going to add them together. 3 plus 4 is 7, and then we keep the x squared. Last up, we have constants. So I have, I don't know what shape to do this time. I'm just going to underline them maybe. I have a 20 and a 9. They're both positive, so I add them together and get 29, and that's just my answer. All right, our last example, example 3. This is a subtraction problem. So you guys see that it's a subtraction problem. Whenever it's a subtraction problem, you always distribute the negative to start. So everything in front of the subtraction sign stays exactly the same. But what happens is your subtraction sign is going to distribute to all of the pieces that come after it. When you distribute a negative, it changes the sign. So my positive 12x squared turns to a negative, or no, it was the 12x to the 6th, turns to a negative 12x to the 6th. My positive 4x to the 5th turns to a negative 4x to the 5th. My negative 2x becomes a positive 2x, and my positive 1 becomes a negative 1. So everything in front of the minus sign stays the same. What comes after the minus sign, you distribute that negative. All right, now we're going to combine any like terms. So I'm going to start with my highest exponent. The highest one I see is a 6. So I have these right here. I have negative 1 here, even though it's not written, there's a 1 here. And I have negative 12 here, so they're both negative. I'm going to add them together. 12 plus 1 is 13. Keep it negative. X to the 6th. Let me go down in descending order. So after 6 comes 5. I only see one of them, though. I'm going to put a square around it. So minus 4x to the 5th. Then I see a x squared. That's my only other one. I'll put a triangle around that one. I have plus 7x squared. Then I'm going down to my x's. I have a plus 2x. I'm just going to underline that one. So plus 2x. And then the last one I have is constants. So with constants, I don't know, maybe I'll put like a squiggly bubble around them. I have an 11 and a minus 1. So if you have a positive 11 minus 1, 11 minus 1 is 10. Keep it positive. And that's our answer. Okay, so everything's been reviewed. What are you supposed to do now? So please, you need to take pictures of page 19 and 20 examples. You're going to paste them into your, copy and paste them, the pictures, into your digital notebook on slide 10. You can use your sticky notes on the side of slide 9 to add in questions and a summary of what the notes are about. And then be ready tomorrow to do some practice of adding and subtracting polynomials. All right, thanks.